Okay, so we're going to go through some properties of logarithms. We're going to stick with log base 10. So the first one here is, what if you have logarithm of a product? Okay, and what this will do is you can take the log of A and then you can add it to the log of B. And this works because basically we're using those properties of exponents and kind of doing it backwards because these are inverses. And underneath this, I'm just going to mark something separately that I want to point out doesn't have a trick. Okay? If you have log A times log B, like that, that exists, that's something that you can use, but there's no trick. It doesn't become log of A plus B or anything like that. Okay? The trick is if you have a product inside, you can sum the two logs outside. All right? The next one, you can also do this with division. And this will just become subtraction. And even though I'm doing this for log base 10, this actually works for any base, any logarithm to do this. And again, I want to point out, if you have logs like this, we'll see a different trick with those later, but this is not something where you could do this kind of trick. You can't make it log of A minus B. And maybe another thing to point out is that if you have this inside the logarithm, so you have a, just like I'm pointing out, if it's multiplication or division outside, if it's addition or subtraction inside, that exists, it's something you can use, but there's no trick. Okay, that doesn't do anything. It has to be multiplication or division inside, addition or subtraction outside. And the next one we're going to use to solve some equations. If you have something like this, where you have a to an exponent, if you think about that as multiplication repeatedly, you can just bring the exponent out front as a factor. And so that means when you have like an x in the exponent, you can solve by bringing the x out with logarithms. And so that's a reason why sometimes we'll introduce logarithms to an equation that doesn't have any. And the last two are related. What we said was that log base 10 and 10 to the x are inverses. So that means if I take log of 10 to the x, inverse is composed of just x, right? So they should simplify that way. And then the other one looks a little weirder, but if you take log base 10 of x, and you take 10 to that power, you just get x. And that's something you're allowed to do to an equation, is make both sides the exponent of a base. And so that shows both ways that they compose, they simplify.